Hi there, I'm Dave, a former alumni of Miss Gabrielson's AP Computer Science class back when she used to teach AP Computer Science at Centennial High School. So a little over a decade ago, actually. The reason I'm making this video is that she mentioned that some of the kids in her class were saying that there's no importance to commenting your code or documenting your code because if you write really clean code, well-designed code, then there should be no need for comments. And so, is that statement true? Well, the real answer, like it is for a lot of things in the math and science world, is it's sort of true. As in, there's times when you're right that if you have to keep commenting every line of your code, that usually indicates some bad design or some ugly, like your code's not modularized or organized in a clean manner that makes it very easy to understand what it's trying to do. Then yes, that's true. You should not. If you're adding comments to compensate for bad design, then yes, that's not good, obviously. But there are times when comments are actually very important. And in fact, I will actually show you examples of very popular, famous open source libraries in the Java community. Apache libraries, Google libraries, and even native Java libraries that are well commented. And you'll see why they're well commented. The short answer, of course, is the syntax of a programming language cannot always capture every single amount of interface information or protocol obedience information about how a certain interface is supposed to work, how certain code is supposed to work. What do I mean by that? Well, what I mean by that is that you might have already learned the concept of, say, polymorphism in your computer science class in high school. The idea is that you have this common protocol or common interface if you're doing it in Java, where you have, for example, if we have a person, if you're trying to access a person object that's stored in some database, right? You'll probably have a get method where you'll give some kind of key or ID to pull that specific person out of that database. And of course, you'll have a method to create or put a new person into that database, right? And so the specific database itself should not matter to your code. If you're using getting people and creating people, it should not matter. You shouldn't have to care if you're getting or creating people from an Oracle database, from a Cassandra database, which is a different, if you ever heard it, don't worry about it, from a MongoDB database. Like, it shouldn't matter to you as the higher level programmer who's using this person interface. DAO just means data access object. So this person data access class to get and put people in the database and to get that, you don't care about the underlying. You should not have to care. Because the idea is that suddenly if we swap databases under the hood, your code does not have to change. Your code that's getting people and creating people should never have to change. If it has to change every time someone changes the database, if you have to change your code to accommodate that database change, that usually indicates a bad design, right? And so what I was getting at was that sometimes sometimes the design of the language can't capture all that information. For example, Java's native annotations has a non-null, but not a non-empty, for example. So you might want to mention that the input string, it shouldn't just be not null, but it should be non-empty as well, because that will be checked. So it says, so you could write a note, you could write a java comment here that says, hey, if the input string is null or empty, an illegal argument exception will be thrown. So this is not just information to the person using the interface, but this acts as information even to the person who's going to create a new implementation for this interface. Because right now you maybe have an Oracle implementation and a MongoDB implementation, but now suddenly you need to make a Redis, which is a cache, a Redis implementation of this data access object. And you need to make sure you obey the same kind of access patterns and write patterns that the other implementations are doing so that the caller doesn't encounter unexpected behavior. And I'll give you an explicit example of that. For example, this get method says that if the person is not found, you should return null. See that? If they're found, you'll get the person, but if they're not found, you should return null. There's nothing really in the syntax of the Java language here that can tell you that that's going to be the case. You could say, oh, maybe I can use optionals, but even then, optionals can still be returned as null if you're not careful. And so there's conventions that sometimes cannot be like expressed in just the language alone, which is why for an interface class, it's usually really important to document your interface classes at the very least. Your interface classes should be documented because the idea is that someone who's going to use this interface, they should not have to go and look at the underlying implementation classes like these. If they have to do that, it means you have a bad interface. The whole point of an interface is that you're able to just look at the interface, understand how to use it, and you don't have to care. It's basically a black box. You don't have to care about the underlying implementation. It's sort of like your car. If for any of you who's driven a car, once you get your driver's license isn't for a specific car. It's for any kind of car. It's for, like, you can go into a Chevy Tahoe and you can drive that. Why is that? You can go into a Toyota, I don't know, Prius, and you could drive that with that same driver's license. Now, why is that? Well, the idea is that all the cars implement the same driving interface. The wheel works the same way. If I rotate the wheel clockwise, the wheels go in the same direction in all those cars. If I rotate it counterclockwise, they go in the same direction in all those cars. And I press on the accelerator or the brake. Basically, those are all interface. That's the driving interface for the car, right? And because it's kept the same or consistent across all the cars, you don't have to worry about how each car implements that driving interface, how those pistons move, how the wheels actually get turned from all that force. Like, they may each do it slightly differently, but you don't have to worry about those details. And the same applies in software engineering. You need to make sure that your interfaces are so good and well documented that people understand exactly how they behave, no matter what assuming, of course, the implementer of those classes are obeying the interface as well. But that's a contract, basically, between the user of the interface and the implementer of the interface. This interface class is like the contract that they both kind of sign on to, and that allows them to develop independent of each other, but also not break and not mess with each other. So let's give a specific example here. Is I've made 3 different classes. Pretend this could be like 3 different databases. One just uses a array list and stores objects in an array list to simulate a database. You can see that, we create person, create a random ID, add a person to the array list. Same with the linked list. In fact, you could probably comment out the code. Since the linked list and the array list are both using the list interface, you could probably just have one class. Or you can make an abstract class or something like that to save up on code. But this is not what that talk is about, so don't worry about that. But yeah, so these are the implementations. And here what I did is I introduced an intentional bug here where in the case of, remember how we said the get person should return null if the person is not there? If you look at the other two, that's exactly what they do. See, they try to match up. If that person's not there, if the person's there, return it. But if they're not there, return null. And that's the same for the array list. So they're obeying that get person interface. However, the hash map is not, and I intentionally did this just to show an example, it's going to throw an exception saying person not found instead of actually returning null. And this is a perfect example of how the interface didn't indicate that. See, if the implementer doesn't obey this interface, when you write code, you're going to assume that it's not going to throw an exception but return null if the person's not found. So that's going to affect the way you handle the code. If they were going to throw an exception, you'd write the code a different way. But since they're actually, the documentation says it's going to return null, that's how you're going to handle the code if you don't find the person, right? So it really does. The importance of obeying the interface can actually affect correctness in code if people swap implementations, if one implementation doesn't obey the interface. Here, so I wrote an actual little unit test to kind of make this example clearer. So for example, what we do here is I have this factory class. It just gives you, if you want to see the code, it's basically, it basically has singleton instances. Don't worry about the words I'm using. It just means I'm making one instance for the whole app of each of these objects. And normally you wouldn't do this. You would use like a framework like Spring or whatever. But again, this is just a toy example. And then I'm just making sure this factory class will return you one of those objects. Because the idea is that you don't want to keep making multiple instances of these objects that should just be single objects anyway, this data access class. Anyway, don't worry about that, but let's keep going. So basically, I've now created an instance of each of those implementation classes, the array list. All of them have the same interface, that person DAO interface, right? I'll put them in a list. And so now what I'm going to do is I'm going to test that they conform to the contract, to the interface contract. So this is why unit tests are important, right? You can make sure that someone's implementing class didn't break something. And so what we're going to do here is, this is the happy pass test case, right? Where we want to make sure that if you're given valid input, valid create input, valid get input, you should get back the the right person. So person DAO, blah, 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 blah. So here what we do is we create a person, a valid person, because we set, if you go look at the implementation method, as long as a valid person is someone that, as long as you give them a display name and an age, they're considered valid. That's what the interface said, I think. Or if it didn't, it should say that actually. It may not have. So then that's why it's important to put that information in the interface. Or in the interface, you would, in your Java doc, you will link to some external documentation mentioning whether it's a valid object, because that person object can grow over time. So usually, sometimes some teams will put documentation in a separate place and just link to that. And what are required fields, what are optional fields, that kind of thing. Yeah, so let's keep going. Create an object, assert true, so that I make sure that if it's a valid create, you should get back a non-empty ID, right? And in fact, what I'm going to do now is we should actually try to actually get these people from these databases. So actually, I forgot to do the get part, which is really important, right? So let's do a get this, and then we should get that final person. What's it? Person DTO. Person retrieved. TB, right? And then what we can do now is we can say assert. Well, one, this we should have found the person, so it shouldn't be null, right? First thing to check. And second thing is it should be exactly equal to what we created. So there's the expected person, and then there's the one that we got from that database. So let's make sure they're the same. And let me just rerun. I'll just rerun all the tests because it's really fast. Yeah, so if you actually saw, this method actually still passes. So it's good. So it looks like all of them are implementing a valid create and get scenario correctly. Awesome. Now, what about an invalid create, which means, say, I'm just making an empty person, so it's missing some required fields, right? So here now, I'm going to test to make sure that when I create the invalid person, and that illegal argument exception, which I wrote in the interface, will get thrown. That should actually get thrown. So what happens is if it doesn't get thrown, it'll go to this next line, which will fail the test, because we should not have reached that line because we expected an exception to be thrown. And notice how I'm catching that precise exception, illegal argument exception, because I don't want to just catch any exception, because it's a regression if it throws a different kind of exception, like if it throws a illegal state exception, for example. That's not what we wrote in the interface. We said illegal argument exception. So that's really important, right? So that's how we can catch those kind of failures, because this will only catch illegal argument exception. So if that app threw an illegal state exception, it wouldn't catch that. It would actually then fail the test, the entire test. So that's good. And then last thing, yes, so this is the one that's actually failing. So let's see why it's failing. So here what we're doing is we're going to get someone that doesn't exist. See how we're getting it? In the interface, we're supposed to get back null, right? But as you can see, in the hash map one, it did not actually bring back null. It actually threw an exception, which is why I caught the exception, and then I fail it. So I can say I caught the exception, and then I fail the test, and then I write which class actually did the fail. So when I do get class, you actually get even though remember they all have the same static type, which you will learn in your Java class, person DAO, they have different dynamic types, the right-hand side, right? This one's that array list. This one's a person DAO array list. The other one's the third guy is a person DAO hash map impl. And so when I do DAO.get class, I get that dynamic type. So I know which one it is. So it's the hash map one. And then, yeah, and so it failed to conform to the interface. Makes sense. And so that's how I know I have a bug. And so that's how I'd be like, oh, I didn't obey the interface. Whoops. I should not have done this. I should have just, done something like this. And then return. And then now if I run my test, hey, it passes. Yay. Okay, so I know I didn't cause it. So now we know we can safely switch between those implementations. Someone who's using it will always just inject the interface. They'll inject this interface class, if you notice, this class, right? And then during the time of injection, either they'll manually inject if they make their own factory if they're not using any framework, or if they're using Juice or Spring, it'll auto-inject. Don't worry about that. It'll actually inject whatever dynamic class they specify in the Spring config or the Juice module configuration. You can look that up on your own, but don't worry. It's basically a way to take away this boilerplate of having to do factories and stuff all the time. You get to basically those frameworks, spring injection and juice injection, take care of that for you. It's called a dependency injection. The design model that works well with it is called dependency injection, but that might be a little more advanced. Don't worry about that if you're learning, basic CS. Just learn your data structures and all that stuff. All right, cool. Yeah, so what I wanted to mention also is a lot of open source libraries use this stuff. So let me give you an example. If I go into this implementation here, you can see something like, yes, UUID, random UUID. So this is actually a Java native class. You see how there's a ton of comments here, right? Because UUID, it's just universal unique identifier. It doesn't, but what kind, how is it made, how is it generated? Well, that's why you need a good comment to explain that, right? It's really important. You need to know how this UUID is being generated, because there's different ways of generating UUIDs. And so the there's the official documentation saying what a UUID should be, but then there's many ways to implement that, which is why they're explaining how they're implementing it. And any of the public methods, right, which is the methods going to be used by me or you, the public constructor, the public methods, they give very good. These are actually Java docs. The IDE is actually making it look pretty, but this is what it really looks like. So see, it's all Java docs. So I would say public-facing things that other people are going to use that you're building, like your interface methods or any public static factory classes, anything, you should actually put documentation, Java docs on those methods, kind of explaining what they do, right? Now, don't take my word for it. Look at all those famous libraries, like, let's see, what's a good one? There's probably string utils. So Apache Common, the Apache libraries are very common. So you see the string utils class, it has the isEmpty method to check if something's null or empty. So it mentions right here, checks if a character sequence is empty or null, blah, blah, blah. And so this is just a Java doc, right? Cool. And yeah, see, the cool thing about Java doc comments is that many IDEs, like this one, will actually pretty format them and then make them look all cool. And then see, it's just much easier. You don't have to worry about the underlying implementation. In this case, it's just one line, but it could be a very complex implementation. For example, if you go to like Apache HTTP client or something, let's see. Yeah, I mean, there we go. So if I go in here, see, this could be a much more complicated. This is an interface, so by properly defining the interface, I don't need to know the exact implementation class, right? And that's the whole point of a good interface. Now, if I actually go in here, like, see, I should not have to know about how it's actually implementing this HTTP client, right? Like, there's a lot of detail that I should not have to know. I just want to make HTTP requests. And so all I need to do is look at this interface that tells exactly how anything that's implementing this interface will behave. All right? And so, yeah, so hopefully that gave you some insight into comments and documentation. And I can tell you at the 2 years I worked at Microsoft and the 5 years and counting that I work at Apple, documentation is very important. And even at the startups that I interned at back in college in Palo Alto, they also, were pretty big on commenting at least anything that was public facing. So yeah, my advice is you don't have to comment every little line of code if you're writing obvious stuff, but if you're doing a really complex algorithm, usually those will have line comments if it's a non-trivial algorithm with some tricky stuff inside it. But beyond that, yeah, most code does not have comments other than public-facing interface definitions. So like Java documentation on public methods, on interfaces, things like that, right? And then people will respect you more. Like they will trust you as someone who builds high-quality libraries because they're well documented and they can be used easily. And yeah, that's it. It's not much more of that. Hopefully I've convinced you that, documenting your code well is actually important in the real world. Take care.